So concentration is just the way that we measure how much solute happens to be dissolved in a solution. And we all know about concentration, right? A solution can be either concentrated or dilute. That's the difference between strong coffee and weak coffee, right? You can get a concentrated cleaner, which you have to add water to dilute it to its proper concentration. So there are lots of ways of expressing concentration specifically, and we're going to talk about two of those ways. Mass percent is a very commonly used method for expressing concentration, especially in healthcare. Some of you will be going into healthcare, so it's good to have some idea about how this works. And concentration by mass percent is one way of expressing concentration. It can be as a volume percent too, but we'll talk mostly about mass percent. And so here, mass percent, it's just the same way that we did percents before. It's always going to be some portion divided by the entire amount, and then just times 100 to make a percent out of it. But what we have to be really careful of is that we're taking the mass of solute divided by the mass of solution itself. Remember, the solute plus the solvent combine together to make a solution. So this, what we say here, the bottom of this fraction is the total mass for the entire solution, right? So if we look at this problem right here, to calculate a mass percent, we just have to do that division, right? If we got 12.1 grams of NaCl, it's dissolved in that many grams of water, mass percent. Obviously, it's going to be the 12.1 grams of sodium chloride because that's the solute that we dissolved, okay? But be careful. We're not going to divide by 120.1 grams of water that we added. Mass percent is mass of solute divided by the mass of the solution. So we have to add up the 12.1 grams of the solute plus the 120.1 grams of the solvent times 100%. So I would add those up first, right? It would be 12.1 divided by 132.2. That's the solution. 100%. Okay. If you just do that division, you get a number between 1 and 1, or between 0 and 1, right? It's just the fraction out of 1, okay? But to get a percent out of that, out of 100, you just do times 100. So the answer for that one should be 9.15%. If we do it to 3 sig figs, if we have a problem like this one where you're given a percent to work with, there's a couple of ways that we can deal with that, right? First, let's read the problem, make sure we understand it. What is sold as bleach, okay, is actually a 6.25% sodium hypochlorite. And it's an ionic compound. There's sodium, there's hypochlorite. It's a solution in water. What mass of sodium hypochlorite? Sodium hypochlorite is like the active ingredient, okay? But the bleach is only 6.25% that. The rest of it, it's water. So what we can do, if you're ever given a mass percent, you can make a conversion factor out of it. You can make a fraction so that you can solve a unit conversion problem out of it. Okay? If we have a 6.25% solution, right? Percent means out of 100. If I had 100 grams total of solution, it would just contain 6.25 grams because that's what 6.25% means, right? Percent means out of 100. Okay? So that means what we can do is take the value that we're given, 487 grams of bleach, and make a conversion factor so that grams of bleach cancels, and then I can solve for grams of NaOCl. Now let's take this information that we're given here. 100 grams of the entire solution contains 6.25 grams of NaOCl. So the bleach here is the solution, right? The solution is the total mixture. So that's 100. All this fraction is what 6.25% really means. And I like this way of doing it because this makes you understand that 6.25% means we've got 6.25 grams of that active ingredient out of 100 grams of the total solution. So it's just a way of canceling out the units. You'll do 487 times 6.25 over 100. It's just 30.4 grams of NaOCl. And the nice thing about this is it's easy to check your work, right? Really, the only mistake you could do here was setting that fraction up wrong, okay? Or maybe trying to start out with a conversion with the percent, but you can't do that because that percent doesn't cancel with anything. But if you look at this number here, it should make sense based on how much bleach that we have. All right, if I've got 487 grams of bleach, which is the solution itself, and only 6% of it or so is the active ingredient, well, that makes sense. That seems like it's about 6% of 487. Obviously, if you're good with math, you could just do 487 times 0.0625. Right? That's just the normal way of doing percents, right? 6.25% is 0.0625. Okay? So that's why you do percents in a math class, but here in a chemistry class, I think it's really nice to be able to cancel those units out, as well as be able to have, I mean, it's the same exact math. It's just nice to be able to have that sort of conceptual understanding of it. And this one right here, 17.2 grams of acetic acid. I'm not even really reading the problem. All I see is I've got some grams, I've got a percent there. Let's look at the problem. Vinegar, right, or you get at the grocery store, 5% of that is acetic acid. Acetic acid is the active ingredient. You probably smelled acetic acid in the ester lab that you did this year. So if I've got 17.2 grams of the acetic acid, how much vinegar can I make? Well, I'm going to be looking for an answer that's much larger than 17 grams because that's just the active ingredient. That's only going to make up 5% of the total. I can interpret this total as saying there are 5.0 grams of acetic acid per 100 grams of solution of vinegar. So cancel the unit. The answer I would get on this one would be, if I do it to 2 sig figs, it would be 340 grams of vinegar. If we want to avoid that trailing 0, we could do scientific. We could do 3.4 times 10 to the 1 grams. Okay, so again, make sure your sig figs are right from there. So this method of unit cancellation is just one way of visualizing that percent, right? Really, this is no different from any other percent question that you might be asked somewhere else. It's just you have a little lower chance of doing the wrong math if you have some kind of understanding of what it is that you're converting, right? So if you're given a value, you're given a percent, make that percent into a conversion between the part, right, between the active ingredient and the entire solution. And that percent is just that many grams of the active ingredient per 100 grams of the total solution. So it does require some reading comprehension, right, that you understand which one of these is the total solution, which one of these is the active ingredient. But practice a little bit setting it up that way, and I think you'll be happy with how that works for you.